tutorial we're looking at the basics of y equals mx plus c. So firstly, what is this? This is the general equation of a straight line graph. So let's consider some xy axes and the equation y equals 2x minus 1. If we were asked to plot this graph, we would want a table of coordinates and we want to pick a few coordinates so that we can then plot them on our curve, on our axes. So this is going to be a straight line, not a curve. So we're going to substitute our value of x into our equation. So that's y equals 2 times minus 2 minus 1. So 2 times minus 2 is minus 4, minus 1 is minus 5. And we repeat, 2 times minus 1 is minus 2, minus 1 is minus 3. 2 times 0 is 0, minus 1 is minus 1. 2 times 1 is 2, minus 1 is 1. So we're going to plot these. So we imagine that we've got some axes, minus 2, minus 1, 0, 1. And then 1, 2, 3, minus 1, minus 2, minus 3, minus 4, minus 5. And we plot minus 2, minus 5, minus 1, minus 3, 0, minus 1, and 1, 1. And we join with a straight line and we extend it for the whole axis. Things that we can consider and what we can see. The first thing is that it crosses the y-axis at minus 1. And this is what we call the y-intercept. So for any straight line in the form of y equals mx plus c, our c represents the y-intercept. And the m here, in this case, is 2, represents the gradient of your line. Now you may have been taught a few different methods to find the gradient of a straight line. To find the gradient, we can say it is the change in y over the change in x. Some people refer to this as the rise over the run if we use that triangle. Now sometimes you don't get an axis, you just get a set of coordinates. You need to find the gradient of the straight line just from a set of coordinates. If you're doing the higher paper, my suggestion would be to just learn this equation. All it is a numerical representation of change in y, the difference in the y coordinates, divided by the difference in the x coordinates. So let's try. On our axes to the right, we've got a change in x. We're going from minus 1 to 1, so that's a change of 2. And then we're going from minus 3, and we're going to 1, so that's a change of 4. So our gradient is our rise, our change in y, which is 4, divided by our run, our change in x, which is 2. Our gradient is 2. That confirms it. So if we're looking at some other examples of y equals mx plus c, some straight line graphs, and we were asked to identify the gradient and the y-intercept. Y equals 3x minus 7. 2y equals 4x plus 10. 2y minus 8x equals 14. And 3y plus 9x minus 12 equals 0. With our first equation, it is in the form of y equals mx plus c. So we can straight away identify our gradient is 3 and our y-intercept is minus 7. Our next equation is not in the form of y equals mx plus c. It's 2y. So in order to get to y, we need to divide our entire equation by 2. So that gives us y equals 2x plus 5. So in this case, our gradient is 2 and our y-intercept is 5. so you have to be careful with what format your equation is in. Similarly, in our next one, not in the form of y equals mx plus c. So we're going to add the 8x to both sides so that we're ending up with our y on its own. And then we need to divide our entire equation by 2, leaving us with a gradient of 4 and a y-intercept of 7. Same again, 3y, we're going to take away the 9x and we're going to add the 12. We're going to divide our entire equation by 3 so that we just get 1y. Our gradient is minus 3 and our y-intercept is plus 4. You may also see equations that have a fractional gradient. That is fine, it just means that the line isn't as steep. So let's look at an example of a question where we have to find the equation of the straight line that passes through the coordinates minus 2, 10 and 5, minus 12. So what we're going to do here first, so our straight line passes through A and B. We could draw a sketch if we wanted to, but first thing, in any case with equations of straight lines, we want to consider what the gradient will be. So that's y2 minus y1 over x2 minus x1. So we pick our coordinates, x and y, x and y. We can call this set 1 and we can call this set 2. So that's minus 12 minus 10 over 5 minus minus 2. Be careful of your signs. That's minus 22 over 7. So we could try and simplify that if we wanted, or make it into a nice decimal, or we could just leave that as a fraction as is. So for the purpose of this, we're just going to leave it as a fraction because that is not going to leave us with a very nice decimal. Minus 22 over 7x plus c. Our next step is that we want to find out what the y-intercept is. So how do we do it? Now the only way that we can find out a missing letter is if we can know or substitute in known values for your x and y. So that's exactly what we do. We pick a set of coordinates. So when y is 10 and x is minus 2, that leaves us with our one unknown letter. Minus 22 over 7 multiplied by minus 2 is positive 44 over 7 plus c. Then we're going to take this away. So that's 10 minus 44 over 7 equals c. A little bit of fractions recap for you. That is 10 over 1 minus 44 over 7. We need the same denominators, so we're going to multiply our first fraction up by 7. So that leaves us with 70 minus 44. Now our denominators are the same, so that is 26 over 7. So c equals 26 over 7. So this example purely is showing you that you might not end up with nice whole numbers, but you can still be done.